Hello Chem 1A, this is Chapter 5, Lecture Video 1. We're going to be talking about stoichiometry. So stoichiometry is really the study of mass relationships in a reaction, right? So it's probably by far one of the more important things we talk about in Chem 1A because it has so much application to industry or really anything, right? If you think about this, think about baking a cake. You want to bake a couple cakes. Well, the first thing you need to know is how many ingredients do I need to go buy before I can make these cakes, however many I want to buy, or make, sorry. Well, that's kind of what stoichiometry is. It allows us to calculate the mass or the amount of reactants that we need to have in order to produce a specific amount of product. Or maybe I want to know, hey, if I use this amount of reactants, how much products am I going to get out of this reaction? These are all calculatable using the mass relationships involved in a reaction, or in other words, stoichiometry. It's going to give us quantitative numeric values for our chemical reactions and how much we make, how much we used, all these things. It's all based off the principle of that mass must be conserved, just in a chemical reaction, just like anywhere else, right? The law of conservation of matter is in a big role here. In other words, the total mass of the reactants that react are going to be equal to the total mass of products that are made. Or in other words, the number of atoms on each side of the reactant side to the product side have to be the same as well. These two things go together, right? What I'm showing here is all about balanced equations, which we learned about in the last chapter. Now, we need a balanced chemical equation before we can do any calculations involving stoichiometry, and so that's why I bring it up. All right, so stoichiometric coefficients, or the stuff we put when we balance a chemical reaction, these are very, very important in stoichiometry. They give us a ratio of reactants to products in the reaction. And from this ratio, I can create conversion factors, right? So let's show that, right? Balancing coefficients, they allow us to convert between amounts of reactants and products, or reactants and reactants, or products and products. Here's the combustion reaction of ethane, right? And as you can see here, we have 2 ethanes react with 7 oxygens to give us 4 CO2s and 6 H2Os. Now, what that means is every time this reaction occurs, 2 ethanes are gone, they've been used up, and 7 oxygens have been used, and in the process we've formed 4 CO2 molecules and 6 H2O molecules. This allows us to create ratios, specifically what we call mole ratios, between reactants and products, or products and reactants, or products and products, or reactants and reactants. For instance, if we look at the ratio between oxygen and water, we can actually get 2 different conversion factors. I could have 7 moles of O2 over 6 moles of H2O. And this is one conversion factor I can use, and the ratio between oxygen and water. The other option would be 6 moles of water over 7 moles of O2. And where am I getting these numbers from? Well, pretty straightforward. I'm getting the numbers from the balanced chemical equation. Okay, so let's use these in action and actually solve for some moles of products based on how many moles of reactants we know have reacted. For instance, let's look at this balanced chemical equation. If I tell you that I want to make 4 moles of IF3, IF3 is right here, how many moles of I2, so how many moles of I2 do I need in order to make 4 moles of IF3? Well, I can calculate this using the fact that I know 4 moles of IF3 here is what I want to make. Then I can use a mole ratio here to figure out how many moles of I2 I would need. I know that every time this reaction occurs, I form 2 moles of IF3. And over here we don't have a number because it's 1 technically, right? We don't show the coefficient 1. So I know that every time this reaction happens, 2 moles of IF3 are formed and 1 mole of I2 is formed. So I can go 1 mole of I2 in this numerator. And as you can see here, the moles of IF3 are going to cancel and we're going to be left with moles of I2, giving us a value of 2 moles of I2 would be required to make 4 moles of IF3. So let's do another example problem. What if instead of making 4 moles of IF3, I want to make 12 moles of IF3? And this time I don't want to know how many moles of I2 I need. I want to know how many moles of F2 I would need to do that. Okay, well, again, we know we have 12 moles of IF3. That was given in the problem. And I know that 2 moles of IF3 are formed every time the reaction happens, and 3 moles of F2 are used every time this reaction happens. So if I do this out, I'm going to get that I need 18 moles of F2. And we can see that again, the moles of IF3 cancel. We're left with moles of F2, which is again what we were being asked for in the problem. So using mole ratios is the heart of stoichiometry problems. We need the balanced chemical equation first. That allows us to get these mole ratios, which allows us to convert from units of one substance, like in this case IF3, to another substance, like I2 and F2 in these two problems. Let's do one last problem with moles. So how many moles of I2 are needed to react with 1.5 moles of F2? Again, I mentioned this on the previous slides. We don't always have to go from a product to a reactant or a reactant to a product. We could go from one reactant to the other reactant, right? I know I have 1.5 moles of F2. How many moles am I going to need of I2 to get rid of all of my F2? Well, I can create a mole ratio for that, right? I know that I want moles of F2 in the denominator so that they cancel. And I know that the reaction has a 3 in front of F2, so I'm going to put that 3 there. I know that I want to get to moles of I2, and I know there's a 1 in front of I2, so I just put 1 in the numerator. Again, if we look at this, our moles of F2 are canceling. We're left with moles of I2, and this gives us 0.5 moles of I2 would be needed to react with 1.5 moles of F2. All right, so that's where we're going to stop here. If you guys have any questions, feel free to let me know.